Okay. Okay, tomorrow we have a makeup class. Then we have another class on Wednesday. 1, 2. Then we have 2 more classes, right? The last class will be probably 2nd of June. Am I correct? So we will have four
Yes,
more classes after this, and we have only one chapter left, that is chapter 6. So we are fine with the syllabus. Okay, let us start. In the last class,
Sir, last class ke sir আমাদের 6 June না?
oh, it's 6th June? Oh, okay, maybe.
Yes,
In
sir.
that case, we will have 5 more classes.
5 class, sir. Yes, sir.
Okay, fine. Yes. No problem. If we finish our syllabus early, we can just have some revisions. And also, we need to take one more in-class assignment. Let us fix that on 30th May. Okay. Next Sunday. I will update about the syllabus on
Yes, sir.
tomorrow's class or Wednesday's class. So let us fix the final in-class assignment on, and hopefully by that time I will update all your in-class marks and homework. And homework 2 deadline is 29th May. Okay, so in the last class we started. Can you see my slides?
Sir.
Okay. We have yes.
Sir, আমাদের ক্লাস টাইমিংটা মনে হয় চেঞ্জ করা হয়নি
Yes, I know that's why you require permission every day. I forgot actually, so hopefully I will do after today's class. Just someone please send me an email, just a reminder email. Miraj, you send me an email, okay?
জি স্যার
Okay, so I will update after today's class. Because it was in Ramadan, it was 11:10 to 12:10, so that's why after 12:10 it requires permission again and again. I will update after today's class. Okay, so I think we have started distance vector algorithm yesterday, and I went through some example, but due to a hurry, actually I could not finish. So today I'm just reviewing from the beginning, and then we will do some hands-on also example. So previously it was linked state, and now we started in the last class distance vector algorithm. What was the basic difference by 2 or 3 words? Anyone? What was the basic difference? Can anyone tell me? Very short. What is the basic difference between linked state algorithm category and distance vector algorithm category? Many algorithms, routing algorithms, can fall into one of these 2 categories.
Sir, in linked state we know the weight or the cost of all the other nodes.
That is entire information,
network,
right?
yes,
Entire network, entire graph, entire database, whatever you can say. And that's why in linked state the protocol needs to collect data in the beginning, so it might take a reasonable time before it can start. But once it starts calculation, then it has no dependency on the neighbors. But in case of distance vector, there is no requirement of every node getting the entire topology. So that in one way it is an advantage, because any node can start the calculation right away. But in the other end, every iteration a node is dependent on the neighbors to get information. So that is the basic idea. So from time to time, each node sends its own distance vector estimate to neighbors. That means every node updates its table based on the information from neighbors. And if there is if there is a new update, then it will also send the update to the neighbors. So it will continue until no node has new update to send. So that is the procedure. And in this case, we will use a new equation. We call this Bellman-Ford equation. In case of Bellman-Ford equation, I have, I think, explained in the last class, but again, you can see dxy. So this x is actually, this x is the source and y is the destination. Then you can see we will take the minimum of v. How? We will take the direct distance, direct cost cx to v, that is already known, because v is the neighbor of x. So if there are 3 neighbors, we will get 3 v's. If there are 10 neighbors, we will get 10 v's. For each v, we will get a distance to the destination by using direct cost cx to v, and then adding the cost to the destination from the neighbor node. So that capital dv to y will be informed from the neighbor by a node. So that is the logic in the equation. And then we have also covered this iteration will continue, this cycle will continue until there is no more update in the table. So it's a iterative and asynchronous protocol, and also it's a distributed and self-stopping. Self-stopping in the sense, if there is no more update, then a node will not send anything to the neighbors. That means self-stopping. So it will automatically know when to stop when there is no more update. Now we have gone through, we have started this example. Let us again describe this. At the starting point, there is a topology. You can see A, B, C, D, E, F, G, H, I, and all the ages are given. And you can see between C and F, there is no link. It's fine. Still, you can go from C to F. How you can go from C to F? The algorithm will give us the path. When? We don't know. How many steps we need to complete? We don't know. But for a particular node, it's asynchronous. Whenever it gets update from home, update from neighbors, then it will calculate. So you'll see by an example how a node will recalculate its own distance vector. We call this distance vector. Basically, this is a table. And at the step 0, we call t equals to 0. That's the initialization. You can see here, every node will initialize its table or its distance vector. Vector means what? Vector means kind of a table, right? So distance vector. Okay. Now, you can see for A, the initial table, the initial distance vector is very simple. A has how many now neighbors? Please participate with me. Very good. 2. Just 2 connections, 2 neighbors. Simple. So you can see in A's initialized distance vector, there are only 2 positive values. One is dA to B. You can see from the diagram that is known to A only information cost up to the neighbors. Then the other part, nothing is known to A initially. So for the first step or the step 0, what you will do, you will see, okay, which nodes has direct connection from A, then you will update its distance vector. dA to A, definitely by default it's 0. Then dA to B, there is a connection and cost is 8. Although we can see there are many different ways A can reach to B, right? But initially, only direct cost will be there. Then dA to D is 1, and all other nodes are not reachable initially, so those are infinite. Is it clear to everybody? Very simple. Only the direct cost will be in the table. Any question? Okay. So likewise, every node will calculate its own distance vector, and what is shown here, after initialization, every node will send update to its neighbors. You can see by the red thick arrows. So A will send update to D and B, right? Then D will
Yes, sir.
send update to A, E, and G. Very simple. Every node will send update to every other node. After receiving the update, that is why it is asynchronous. Whenever a node receives update from at least one of its neighbors, maybe two other neighbors has no update to send. In this case, all neighbors are sending because every node just initialized. So definitely they have update to send. So after receiving the updates, every node will recalculate and change its distance vector according to the new information. We'll see one example. For example, if we every node will compute, but if we see an example for one particular node, it will be clear. Then all other nodes will see the same way. But one other difference between link state and distance vector: in case of link state C, we say okay, S is the source, sorry, U is the source, and then we show only step one, discuss trust table, and then forwarding table of U. We don't need to show calculation of other nodes. But in case of distance vector, since every node calculates independently, asynchronously, so you have to show each node's calculation, or you have to think about each node will update its own table until there is no more update. So how many steps we need, not sure. It might be
স্যার এটাতে লেখালেখি থাকবে আর অনেক বেশি
right,
এটা
right,
আগেরটা
right,
থেকে
right, definitely. But if you think about the question in the exam, definitely I will not ask you to compute for 8 or 10 nodes. If you can compute for one single node, it's fine. So maybe in the question I will ask, okay, show the calculation for node B in the second step. If you can do that,
ওকে স্যার
you can do anything. Okay. Okay, for example, now let us go through one example hands-on. If you use your paper and pencil with me, it will be very simple. Once you understand the logic, very simple. But if you don't participate with me, then maybe it will take some time to understand. So this is the procedure. Now t equals to 1 means every node will receive update from its neighbors. So just take one particular example. In this case, we will think about B. So see, this is the B's initial table. Is it okay? B has how many neighbors?
3 স্যার
3. So you can see neighbors A, dB to A is 8, dB to C is 1, dB to E is 1, and dB to B definitely 0. So that is not specified. But all other nodes, B has infinite value because there is no direct connection. So this is the initial distance vector of B. Now we will see at t equals to 1, at step 1, how B updates its own table. First of all, since B's neighbors are A, E, and C, so we have to see A's distance vector, C's distance vector, and E's distance vector. So we can write down. I will do a hands-on right now. So let us write down this scenario. Please write down this scenario in your script, in your khata. Just you can draw only A, B, C, and E only for this purpose. Other connections you don't need right now, but you need A's initial distance vector, C's initial distance vector, and E's initial distance vector. So let us write down these distance vectors, and then we will see how B updates its own distance vector with updates from the neighbors. So D A dA to A is 0, dA to B is 8, then dA to C infinite, dA to D equals to 1. All other nodes are infinite. So dA to F infinite, dA to G infinite, and dA to H infinite, and dA to I, that is also infinite. Similarly, if we see initialization of distance vector C, then C to A, that is infinite, C to B goes to 1, then C to C is definitely 0. Then DC to D, all other infinite. So I can write down all other infinite. And then,
Sir, are you writing somewhere, sir?
yes, I am writing, but I will share. Just I am writing the distance
Okay,
vector,
sir.
and you can also write down in your khata, so that when I do the calculation, it will be understandable to you. Because in that case, this screen will not be shared. I will share my hands-on screen. So please write
Okay,
down
sir.
this. It will be easy for you to understand. Just one more table I have to write down. That is distance vector of E, dE to A, that is infinite, dE to B, that is 1, dE to C, that is infinite, then dE to E is definitely dE to D, that is 1, then dE to E equals to 0, dE to F equals to 1, and dE to G. E to G equals to infinite, dE to H equals to 1, dE to I equals to infinite. So I have finished writing this topology. We don't need, we will only show the calculation of B. So we don't need other nodes that are not connected to B right now. So now let me just stop presenting here and start presenting in my tab. So if you, I think you can see screen, right? So what I did, I just written down the part that is needed for this. I just omitted other nodes and other connections, and I think you already understand that we are showing the calculation of B for the second step only. We don't know how many steps we need until there is no more update, but this is the second step for B, and B has neighbors A, C, and E. Everyone has its own distance vector, and they sent updates to B. So up to this point, everybody clear? Is there any question? Okay. If there are any question, please feel free to ask. Now, understand the logic. Now B has its own distance vector, but for example, D has in its table, you can see D B2 D equals to infinite, right? Please follow me. From B's distance vector, distance or cost from B to D value is what? D B to D value what?
So infinite.
Infinite. Please follow me and also use your paper pencil. But if you see the distance vector of A, that is update, send update to B, what is the distance from A to D?
1, sir.
1. So just think simple. Just forget the algorithm. Think simple. What is the logic? Initially, B has the information. I cannot go to D because the cost is infinite. Now, if A sends B that okay, from me distance to D is 1, and B knows its distance to A is 8, so B can easily update its table DB to D. There will be no more infinite, right?
Yes.
It will be 9. So this is the logic, but you have to understand the formula, because if there are so many nodes, you cannot simply do it by your just visually or from graphically. So is this logic clear to others also? Anybody has any question? Just this logic we will now implement using the formula, that is the Bellman-Ford equation. Now, what was the Bellman-Ford equation? Let me write the Bellman-Ford equation here. So Bellman-Ford, this is the equation invented by those gentlemen. So we call it Bellman-Ford equation. The equation is, if we write down, dx to y equals to minimum of v, and in this case we'll take c x to v plus d v to y. Now you can you need to understand the logic first. This x is source, okay? This is the source, this y is the destination, and this v is possible next node. We call this possible next node, but basically these are what? Neighbors, right? And if you see all possible values, you can see always source and destination fixed, right? So only what is changed? The neighbors. Possible next node, it is changed. That means what? That means to update its own distance vector, B needs to calculate, in case of X will be B in our case. So here we are working with B, so it will be here X will be what? B, right? B will be the source, and V for V,
So D.
actually for B you have to you know, B has which nodes? A, C, and what other node? E.
sir.
E. Okay, so these are the neighbors, but B needs to update its every entry of the table. So for example, we'll start with, order doesn't matter. You can start with, for example, D, B to A. See, I have written here before update. Before update means this is the stage. This is the state of the table of B's distance vector. Whenever it gets update from other nodes, it will use the information to recalculate its own table. When it recalculates, it will recalculate every possible value. So we'll start with dBA. Let us write the entire equation. It will be easier to understand. So how many values will be there? Anybody other than Rifaz? Anybody? Shudeep? Are you there, Shudeep?
Yes, sir.
Can you tell me how many values will be in this equation?
So no, sir.
Okay, it depends on what? In every equation of distance vector, how many value we can get? It depends on what?
Neighbors.
Right, neighbors. Very simple, because it is always gets update from neighbors, send updates to neighbors. And also in any routing algorithm, the only thing a node can do is forward the packet to one of its neighbors. It cannot send any other node, right? So 3 neighbors means 3 options. That means you will get 3 values. And in this example, you will not see more than 3 values, less than 3 values. But if, yes, Bidhan, good. If you participate with me, it will be easier for you to understand. Very simple. I am taking so much time. See, just I want you participate and understand. So if there are probably, if there were 10 neighbors in each equation, we will get 10 possible values. How? See. So from B to A, B is the source now, A is the destination. What are the possible ways? Don't see whether there is a connection existing in the graph or not. B will now calculate only based on updates from neighbors, not from the graph. B cannot see visually. Okay. So there will be how many ways? From B, we can send to A through A directly. But in this case, for the sake of the equation, we will write dA to A. But you know dA to A is definitely 0. But A is one of the neighbors. What will be the second value? B to
C, sir.
yeah, C. C or E, order doesn't matter. But you have to, okay, if you say C, B to C, then you have to say D, C to. The final destination is always C, A in this equation. And then last value B to any other? Jahid, Khondokar Jahid.
Sir, E.
Very good. E. So C, A, C, E. That means what? That means the number of neighbors, number of possible values. Again, E to A. Now, one thing you don't need to remember, you just need to understand. You see, we never, in every possible value, we never change the source and destination. See? Source, destination. Never changed. Source, destination. Source, destination. Only we change the middle value. Because there are three neighbors. You don't need to decide on your own that, okay, there is no connection between C to A. You don't need to see that. You just apply the formula. It will be, definitely will find the minimum cost. Now, just, sorry. Okay. Now, just put the values B to A, C, B to A. What's the value? Tell me.
Sir, 8.
8. So this is directly known. Okay. So this is directly known value is C. C is the direct value. So that is already known in distance vector. We know.
So C we get from the graph, right, sir? The whole graph.
Yes. The graph means actually it's a data structure. So B has this table already. You know, B has already
Yes.
its own distance table. So
Oh,
we
oh,
already
okay,
know
sorry.
B to A. But dA to N, capital dA to N, that is not from the graph. That B actually gets update from A. So B will use A's table for that.
Yes.
Okay. So from A to A, that is actually 0. In the first case, that is very trivial, 0. But for the second case, DB to C is 1, right? 1 plus C to A, B will take from?
C, sir.
Right, C is distance vector. So what is the C's distance vector now? Let us find out. We want to find C to A. So you can see C to A is what? Infinite, right? So it is infinite. No way you can put, you have to put this infinite. Because still there is no connection from C to A. Then from B to E, what is the value? From B to E is 1. And E to A, it must go to E's table. See, E to A, what? Infinite. So unfortunately, these both values, 1 plus infinite means infinite. So the default value will be 8. So the direct value will be there. Okay. Now for the, similarly, you have to do it. So what we can do, we can write B's table again Or we can show this way. 8, just draw a circle and don't do anything else. That means this has been calculated and not changed. This is the one way you can show. But you can write down the distance vector table again, no problem. After update, no problem. But you can also show that like this way. Now, you have to calculate second one, dB2C. Again, write down the formula. And for the formula, you have to do again like this, C2C, CB2A, DA2C. Order doesn't matter. I could have written this one before the first one. Then CB2E, DE2C. Again, C, always source and destination will remain same. Now, if you just put the values here, B2C, what is the value of B2C? 1, right? 1, and C2C is 0. Then B2A is 8 plus A2C. You have to go to infinite. So infinite. Then B2E, that is 1. And E2C, you have to go to is table, okay? E2C is infinite. So again, there is no change. It will be 1. So just put like this. Put a circle here. And then this has also not changed. Now come to the point. See how algorithm will give us a value that is not directly reachable. So dB2D, first write down the formula. Please use the formula. That will not take more time. That will actually save you time, because once you are confused by doing just with the value, by doing just with your intuitive sense, silly mistakes will be there. So write down the formula. It will be easy. Again, source is B and destination is D. So there are 3 possible ways. DA to D, then C B to C plus D C to D, and then C B to E plus D E to D. Now again, B to A, 8, right? And what is the value of A to D? 1.
Sir, 1.
1.
Yes, sir.
B to C is 1, and C to D, you have to find out C to D is infinite, right? Infinite. Then B to E1 and E to D, you have to go to E's table. E to D equals to 1. See, there are 2 possible values. One is 9, one is middle one is infinite. So the lowest one is 2. Now see, it was previously what? Infinite, right?
Yes, sir.
So infinite, what you can do, it will be a little bit congested, so it's better to write down in a different place. But also you can show like this way. You cross this, you can put like this, cross, and then put a value here, 2. This will be also okay. Is it clear to everybody? So like this, you have to show every possible value. The rest of the thing is your homework. Anybody has any problem, I think just the same way you have to apply the equation, write down the value, and then you have to calculate. And maybe for some other infinite, we might get some possible values. Is it clear? Any question? Okay.
Yes, sir.
Okay, then let us go back to our slide again. Okay, so I hope you understood how it actually worked. So the example I have shown, all the calculations are shown here on the left. See, you can just match with our hands-on. You can get the same thing like this. So for each possible destination, it must recalculate. Maybe for some cases value will change, maybe for some cases value will not change. So after all the calculation, still there are some infinite, because maybe those nodes are not reachable even from the neighbors of B. No problem. There is an update in the table. What B will do now? This is the updated distance vector, final distance vector. Some of the calculations I did not do. You can do it yourself. So everybody clear up to this point? Now this actually shows how a node updates its table, and this will continue. Since B has new update, what B will do? Anybody, what B will do?
So new update হলে তো আমরা আবার iterate করব, তাই না স্যার?
Right. So first thing B will do after the computation is completed, it will send the updates back to the neighbors. Back to which nodes? A, C, and E. So now if I think about the entire solution or entire calculation, now A will again recalculate, C will again recalculate, E will again recalculate. This will continue, and there will be a time when there is no more update, and that we call a converged state. That means in that state the routers will do perfectly forwarding the packets. In the meantime, if a packet arrives, it might not go the correct destination. You have to accept that in case of internet, there are continuously changing costs, right? Load is changing, capacity is changing, links are going down. So continuously, whenever a link is down, what will be the cost? Any idea?
So infinite.
Very good, infinite. Whenever a link can be down for many reasons, like we see in our home internet, right? The line is down. Why line is down? Optical fiber is cut down in some place. But whatever the reason is, if the line is down, maybe they have some alternate. But in case of a real physical link, if the link is down, there is no way packet can be forwarded. So router will do what? Router will recalculate. Suppose the link between B and C is down. What will happen? Which nodes will first know that link is down? B and C, right?
Yes, sir.
So B and C, other nodes cannot know that unless B and C send updates. So whenever a link is down, B and C will first update its own table and send the updated table to others. So that's how.
Sir, recalculationটা তো বাকি সবগুলো নোডের জন্য হবে, তাই না স্যার?
Right. That is why it is asynchronous. Whenever any node gets an update, whenever, if it's about the direct link is down, or it's about the update from one of the neighbors, it will recalculate. So router is a computer that actually recalculates 24 hours a day. If the router is up, it is always recalculating. Its purpose is recalculating. So in this section, actually we saw from scratch how a router creates the routing table. Not only that, there are many cases that actually we have to skip. For example, as I said, if a cost is changed, how the update is accommodated. If a link is down, how the update is accommodated. Actually, router recalculates his own table using the distance vector or link state, but it might take some time to update that information to the extremist node, right? One node can be 10 nodes away, so that will take some time to, but this is how it works. And until that converged state, maybe we will not get 100% guaranteed service. Okay, so see, it is replaced, recalculate and then replaced. So this is the update, and what you will do now, see, B will again send the update to the neighbors, and then again neighbor, it is now showing. Actually, B is sending updates to other two neighbors also. this example now shows the calculation of C similar way. So if you go through this example, I think you can also, you can see in the bottom of the right in the screen, I think during the start of the trimester I told you, and already I think I put a link in the ELMS. There are some interactive exercise by the authors of our textbook, so you can also go through the, go to that link and then go through some of the examples given there. Anybody, any question? So this will continue until all the nodes has updated table that has no more change in the table. But practically, it's a never-ending process because links costs are continuously getting changed. Okay, so it's now there are some comparison between linked state distance vector. Already there are some logical comparison. As I said, linked state initially needs to send some messages to get the entire database. So message complexity may be higher in linked state, but maybe lower in distance vector. But the convergence, it also depends. So there is no better and best, but there are some comparisons. For distance vector, convergence time also varies. That means if there are 10 different nodes, for example, from one node to the extreme possible node, there are 10 possible nodes in the middle, so it will take longer time to converge. But the idea is linked state can take some time to start the calculation, and distance vector can start the calculation right away. Also, distance vector has two problems, may have routing loops. Routing loops means a packet will just go through in a loop. That is a problem. We have to deal with how to recover from looping. And there is one field in the IP header. Can you remember? Time to live. That is one way we can get out of the loop. Time to live is the number of nodes a packet can travel, after which the router will discard the packet. So that is one way. And another problem is count to infinity problem. This is a problem with cost update. If cost suddenly changes, it might take huge time for distance vector. So that is the disadvantage for distance vector. Robustness. What happens if router malfunctions or is compromised? Compromise means security question. If the router is actually attacked by an attacker, or if the router does not work perfectly, somehow it just crashed or not working perfectly, then what will happen? In case of linked state, router can advertise incorrect link cost, because if a neighbor is not giving the correct value, then the node receiving the update will work on that wrong value. Nothing to work, because it doesn't has the entire topology. So a router, malfunctioning router, can send wrong information. That is in the linked state, it is possible. Each router computes only its own table. Already we know. And in case of distance vector, router can advertise incorrect path cost. I think I need to revise this. In case of linked state, since linked state gets update first for the entire database, entire topology, then it starts calculation. How it gets updates? It gets link costs from neighbors, from other nodes. So link costs can be, if a router is malfunctioning, link costs can be sent, not the path cost, not the entire cost from one node to the destination. But in case of distance vector, since the neighbors, see, the neighbors sends distance to a particular node from that node. For example, D, C to Y. So that means it's a path cost, not a link cost. So in case of distance vector, path cost can be wrongly sent, and then the receiving router will work on that wrong. That can happen. We cannot do anything about this. But in case of linked state, each router computes only its own table, as I said already. In case of distance vector, each router's table is used by others through iterations. So if a node receives a wrong value, it updates its own table and sends the updates with the wrong value. So it will propagate, the wrong value will propagate. So these are some of the comparisons between linked state and distance vector, okay? Now the last section, this is actually kind of theory, but we need to know something about routing in the internet, because what we saw, distance vector routing, linked state routing, RIP, or OSPF or EIGRP, these are actually used within an organization. But there are so many organizations, so many ISPs in the internet, how they actually do the routing. The one feature of routing that helps for this is it is actually hierarchy. It is not flat. So far what we have done about the dynamic routing protocol, we assume that all routers are identical and the network is flat. That means all the routers are in the same network. But in practice, this is actually not the case. There are so many ISPs in the middle. So whenever an ISP, whenever a request goes from one node to another node, it can travel many ISPs. So in case of internet, then what is the actually concept? Because there are billions of possible destinations, and it is not possible for each router to contain that entry in its routing table, billions of entry in the same routing table. And also, if the routers, number of routers are becoming larger and larger, and if they always exchange the updates, definitely what will happen? There will be jam, traffic jam. So that's why the process in case of internet actually is a hierarchical one. And let us see how that is done. First thing, that hierarchy is created for administrative autonomy. What is administrative autonomy? Actually, internet is a collection of ISPs. ISPs is a collection of networks. And each network actually controls its own set of routers. So if there are different ISPs, if there are different organizations, they have different set of routers. And in that case, they can use different routing algorithms. Now the problem is, if one organization uses RIP, another organization uses EIGRP, how they can communicate, right? Because think for dynamic routing, every router must follow the same routing algorithm, right? You cannot use RIP and EIGRP in the same network. So then how those two organizations will communicate? You get my point? Question? Because in internet there are so many organizations, each one is using different dynamic routing algorithm. Then how they can communicate? Will it work, you think, if we use RIP and OSPF in the same network? Will it work? Anybody, just think, should it work? It can work, right?
So it might take a lot of time. So
not only lot of time. If you, for example, if two routing protocols has different syntax, see, it will not work. If your message format is different, you're not understandable. So it's not possible. But how many organizations will participate in the internet? Huge. So you cannot make sure every organization, or even these three organizations will use the same routing protocol. You cannot make sure, because every organization is controlled by different administrative, right? Different administration. So that's why we need to know how this is controlled. And the primary keyword here is an autonomous system. So what is an autonomous system? Also, you can call it a domain. You know, a single organization, maybe it has 20 routers, maybe it has 10 routers, maybe it has 50 routers, but all routers are within the control of them, right? So they can use the same routing protocol, no problem. But the problem is when there are different organizations with different control, then we cannot make sure both organizations use the same routing protocol. For example, you are our UIU. In UIU, we are using some dynamic routing protocol. Then UIU is getting connected to an ISP, right? They have also their routers, their routing protocols. Can we make sure that UIU can UIU ask the ISP that you use EIGRP, or ISP ask UIU you use OSPF? It is not actually possible. So how that works? The way it works is dividing the internet, all the organizations, in such a way so that the lowest administrative boundary will be autonomous system. Autonomous system means where in a system, doesn't matter how many routers are there, all routers are controlled by the single organization. So probably UIU might be one autonomous system, might be controlling one autonomous system. UIU might be controlling multiple autonomous systems. Maybe UIU network is so large, so one autonomous system is not work. Autonomous system is actually a concept used in the internet, and it can be actually registered autonomous. So if my network is larger, I can use multiple autonomous system, but one autonomous system will never be controlled by two organizations. You got my point? So the internet is divided into autonomous systems, and these autonomous systems are assigned to different organizations, and one organization can use multiple autonomous systems, but one autonomous system cannot be controlled by multiple organizations. So this is the basic. And now we know, okay, doesn't matter how many billions of networks, millions of networks in the internet, there are autonomous systems. And if there are autonomous systems, every autonomous system is controlled by one single organization. Now it is much more easier to handle. So the routing protocols we have done so far are actually intra-autonomous system. What is intra? Intra-UIU, right? Within the UIU. So intra-autonomous system means it is within the domain, within the network. So the routing protocol we have done in lab, RIP, or there are other protocols, EIGRP, OSPF, or we have done hands-on link state distance vector. These routing protocols can be intra-autonomous system. That means it will only work within one autonomous system only. But in that case, different autonomous system might use different routing protocol. Again, the question is how we can connect those different dynamic algorithms. For that, we have to have another category of algorithms, that is inter-autonomous system, okay? Inter-university. So among the universities, not within the university. So in this case, we cannot employ the normal routing protocols like EIGRP, RIP, OSPF. We must have a specialized routing protocol that will work between different autonomous systems for which there are different dynamic routing protocols. And there are gateways which can be in the middle of two autonomous systems. So they can take data from one autonomous system and forward data to another autonomous system. The idea, is it clear? Any question? Because this is how I will not go through very much details here, but at least we should have some idea about how routing is done in the internet. Okay, any question? Now,
স্যার এখানে
Yes.
ডোমেন গুলা কি যে .net .com এগুলা?
No. This is a different thing.
Okay.
.net.com is related with the server, right?
Yes.
And these are related with the routers,
Oh,
not
okay,
the
sir.
application
Okay,
level
sir.
server. But the idea of domain is always a restricted area, right?
Yes,
In
sir.
this
Yes,
case,
ঠিক
this
আছে।
domain is autonomous system, and the rule is it must be controlled by one single organization. So from that point of view, internet is divided by huge number of, or you just think about an ISP, they are using 5 autonomous systems. Larger ISP, they are controlling 10 autonomous systems. Maybe you can tell, okay, each ISP can control by one autonomous system, but autonomous system also needs to be controlled. So if the area is too large, then it's not easy to control. That's why one organization, if the network is larger, they can also use multiple autonomous systems. But internet is a collection of autonomous systems. Simple. And then each autonomous system will have different routing algorithm, and between autonomous system we must use an inter-autonomous system routing algorithm. And maybe some of you have heard about border gateway protocol, BGP. So border gateway protocol is the protocol that works inter-autonomous system, but that works with the combination of inter-autonomous system also. So if I use RIP in one autonomous system and ISP uses EIGRP, still ISP and my organization can communicate using BGP, or ISPs can communicate among themselves using border gateway protocol, that is an inter-autonomous system. For example, if you see this example, it will be much more clear. There are 3 autonomous system 1, 2, 3, and you can see there are 3 routers in autonomous system 3. There are 4 routers in 1 and 3 routers in autonomous system 2. And also you can see possibly this is a relationship between different ISPs. So autonomous system has 1 has connection to 3 and 2, but 2 has no connection with 3. So 2 must know, if I want to forward one of my client's packet to autonomous system 3, I must take help from autonomous system 1. And now how this is done, that is BGP. We are not going through details, but the logic is this. See, every autonomous system will run under its system inter-autonomous system routing, but that will work only within the organization, and they must communicate. How autonomous system 2 will know that I can get to autonomous system 3 through autonomous system 1? How autonomous system 2 router will get that information? Through inter-autonomous system routing. Clear idea? But we are not going to example for BGP. This is beyond this course. But you can think about then how it will look like every routing table, the forwarding table. There will be actually 2 types of entries in the forwarding tables now. One was like before, inter-autonomous system routing algorithms output, and now there will be some new entries for inter-autonomous system algorithm. See, so both type of entries will be there, and inter-autonomous system will be only used when a destination is beyond an autonomous system, like this. Other networks. So for example, if one source is here in the other network, in the left part, and the destination is in the right part, so they must go through autonomous system 3, autonomous system 1, and then autonomous system 2. So suppose router in autonomous system 1 receives a datagram destined outside of autonomous system 1, then how it works? Just see the logic. Router should forward the packets to gateway router. So now what is a gateway router? See, every autonomous system or organization will have some routers that is also connected to another autonomous system. You can see, for example, when UIU connects to internet, definitely there is a router that we call border router or gateway router that is connected to the ISP. So if one ISP is connected to multiple ISPs, definitely there are routers in through which they are connected to another autonomous system. But there are routers that is internal. You can see 1D and 1A. These 2 are actually internal routers. but you can see 1C connected to another autonomous system, 1D, 1B connected to another autonomous system. That means these are what? Gateway routers. What is a gateway? That takes data from one system to another system. So actually these gateway routers has the responsibility of implementing BGP and then informing the internal routers what to do, because you can see the packet is arrived to not a gateway router, an internal router. So the internal router must know how to get to the destination that is out of this autonomous system. This internal router doesn't know that, but this only will know it needs to forward to the one of the gateway routers. So if the destination is in autonomous system 2, it must forward to 1B. If the autonomous system it is autonomous system 3, it must forward to 1C. This type of routing entries will represent the inter-autonomous system routing, and this will be also forwarded to the internal routers too. This is the idea. Now, what 1A router will do? It will learn which destinations reachable through autonomous system 2, which through autonomous system 3, and propagate this reachability info to all routers in autonomous system 1, so that whenever a packet comes to the internal routers also, they will also know, okay, which gateway router to forward the packet. So this is the idea. As I said, RIP, EIGRP, OSPF, these are the most common inter-autonomous system routing protocol. And BGP is the inter-autonomous system routing protocol. But there is not much information about BGP, but the idea we have just described. Any question? Anybody? So this is actually end of chapter 5. So we have finished routing and network layer. So from next class tomorrow, inshallah, we will start chapter 6, that is the data link layer. So anybody has any question before I finish about the routing algorithms? So in chapter 5, you have to go through inter-autonomous system and inter-autonomous system routing protocols, the idea, not any implementation issues. So that is end of my lecture. If there is no more question, then if you have any question on our workbook, you can also ask me. We have some time. Okay, just think about if you have any question in related to workbook or any other, and by the meantime, let me take the attendance. Have 9 and okay, please respond. Abdullah Al Rifat. Abdullah Al Rifat.
Yes, sir. Abdul Al Rifat.
Okay. Inamul Haq.
Present, sir.
Imam Reza.
Present, sir.
Rokonut Jaman.
Yes, sir.
Laila Ishrat. Farah. Okay. Farah Farzana. Fazle Rabbi. Priyobroto. Ifat Haq.
Yes, sir. Sir,
Yes, sir.
Priyobroto. Okay. Priyobroto there. Priyobroto present. Ifat present. Ali Ahmed. Ali Ahmed, Kaushik Devdas,
Yes, sir.
Khurshida Jahan, Khurshida, Samir Ahmed.
Samir Ahmed sir, chat box is present. Yes.
Okay, okay. Mahmudul Hassan. Okay, Mahmudul Hassan present. Fahim Shakil. Fahim Shakil. Abu Sajjad.
Present, sir.
Okay. Nibirud Jaman. Sadman Shakib. Adnan Kobir.
Yes, sir.
Taki Yasir.
Present, sir.
Shahadat Hussain. Shahadat.
Yes, sir.
Okay. Rakibul Islam. Al Shahriyar.
স্যার নেট একটু সমস্যা আছে।
Kar. Al Shahriyar. Okay. Tanvir Hassan. Tanvir Hassan. Sakib Hussain.
Yes, sir.
Mashuke Alam present. Sabbish
রাকিবুলের স্যার,
Sarkar.
রাকিবুলের।
Yes, sir.
Okay. Okay. Sabbish Sarkar present. Abrar Sadiq.
Yes sir.
Okay. Ishtiaq Ahmed.
Present, sir.
Mufail.
Yes, sir.
Mahfuzur Rahman Sifat. Mahfuzur Rahman Sifat. Shafiqul Islam.
Yes, sir. Yes, sir. মাহফুজুর রহমান আছি স্যার।
Okay. Amanta Hussain.
Present, sir.
Okay. Abir Reza.
স্যার মাহফুজুর রহমান আছি স্যার।
Present, sir.
Mahfuzur Rahman Sifat. Okay. Abir Reza present. Jahid present. Laila Ishrat. Yes, Laila Ishrat present. Khalid Ridwan.
Yes, sir.
Okay. Shahriyaz. Tahmina. Okay. Tahmina Tanjin. Muhammad Mahfuzur Rahman. Fazila Nobi. Mahfuzur Rahman present. Fazila Nobi.
Present, sir. Present,
Okay. Ashrafun Nahar. Ashrafun. Okay. Shifa Chaudhuri.
Present, sir.
Misbahul Alam. Okay. Shifa
Yes, sir.
present. Misbahul Alam.
Yes, sir.
Okay. Yasir Arafat.
Present, sir.
Sudeep Sarkar. Sudeep present.
Present,
Abdul
sir.
Rahim.
Present, sir.
Okay. Miraz.
Yes, sir.
Abu Abdullah. Khondokat Sravon. Shah Alam.
Yes, sir.
Okay. Imtiaz Hussain.
Present, sir.
Okay. Rifaz present. Kamrul Islam Tushar present. Dihan Pathan present. Okay. Abu Kibriya absent. Bidhan present. And Shakawat Hussain
Present sir.
present. Okay. Anyone else missed? Okay. So no question. You found no question in network layer?
স্যার একটা প্রশ্ন ছিল স্যার।
Yes, Ishtiaq.
স্যার আমাদের তো স্যার এবার মিড হলো না স্যার, তো ক্লাস টেস্ট অ্যাসাইনমেন্ট আমাদের অনেকগুলো মার্কস বিয়ার করতেছে স্যার। আমাদের কি কাইন্ডলি স্যার একটা বোনাস সিটি বা একটা অ্যাসাইনমেন্ট দেওয়া যায় স্যার, যাতে আমাদের যদি মানে অনেকেরই যদি খারাপ হয়েও থাকে মার্কস, যদি
You
ওটা
have,
যদি কভার করা
did
যায়।
you give the first quiz, online quiz?
না স্যার, ফার্স্টের কুইজটা অ্যাটেন্ড করতে পারিনি।
Okay, then did you submit that in class assignment 2 that was I have taken in the class? Actually, these are the bonuses.
স্যার ওই আপনি যে ইয়ার ডায়াগ্রামের উপর নিয়েছেন।
Right. So I
But
will
ওইখানে
take
স্যার একটু
those
প্রবলেম
as
হয়েছিল কি
bonus.
স্যার, মানে আপনি তো একদম রানিং শিখাইতেছিলেন, সো একটু ভুল হয়ে গেছিল স্যার, মানে
It's okay. it's okay, but if you get, for example, more than 15, right, out of 20, more than 15, then it's
Sir.
okay. Yes.
Skip.
In class assignment 2 or
And 2, sir.
which one?
2.
2 I have
three.
finished. I think no, 3 is last one that I have taken. 2 I have already finished. Okay, so I have there was some for some I have finished I think today. So you can now go through in class assignment 2. Then I will also finish by homework 1 and 2 shortly. So I think you will get the marks soon.
স্যার
Okay.
আমাদের তো আরেকটা সিটিং
ক্লাস অ্যাসাইনমেন্ট 2টা স্যার আমার ফিডব্যাক দেওয়া হয় না।
Sorry, Ms. Baul.
আমার ফিডব্যাকটা ইন ক্লাস অ্যাসাইনমেন্ট 2 এটাতে ফিডব্যাকটা দেওয়া হয় নাই, মানে অনটাতে আছে কিন্তু
It's already finished. Already finished before the class today. So just check now. Okay, I have finished today,
ওকে স্যার।
and I will gradually finish all the homeworks also, hopefully within this week. So you will get in class assignment 1 and in class assignment 2 finished. So you can check now. Yes.
স্যার হোমওয়ার্ক বলতে কি স্যার হোম অ্যাসাইনমেন্ট
Yes, home assignment 1, home assignment 2.
হচ্ছে আমি পাই নাই স্যার
Okay, yes, sir. You just check now.
Yes,
ELMS.
I have just checked recently.
Oh, did you submit in ELMS?
No, sir.
Oh, but I think uploaded. So just send me an email, okay? Send me an email, then I will check.
Sir, should I will I reply the exam paper?
No. Just send me an email because you have submitted the exam paper. I have to check whether you have I have updated in ELMS or I have updated offline. So you just send me an email, okay? I will inform you. For all others, up to in class assignment 2, evaluation is finished. Homework 1 and in class assignment 3, I have to check.
স্যার ইন ক্লাস অ্যাসাইনমেন্ট 3 এর সলিউশনটা দেয়া যাবে?
Okay. Yes. In class assignment 3 was about net, right? Net and okay, I will give you next class tomorrow. I will give you the solution. Any other question?
আমাদের তো আরেকটা অ্যাসাইনমেন্ট নেবেন ইন ক্লাস অ্যাসাইনমেন্ট 4 নাম্বারটা।
Right. That is next Sunday.
স্যার আমাদের ফাইনাল সিলেবাসটা কি আপনি এলএমএস আপলোড করে দিবেন যে আমাদের ফাইনালে যতটুকু সিলেবাস থাকছে?
Of course.
স্যার একটু আর্লি দিলে ভালো হতো,
specify
তাহলে
everything.
প্রিপারেশনটা আর্লি শুরু করে দিতাম।
Okay, actually I was waiting for the decision from the department, so that's why maybe by next week. Next week means what? Next week means we have 5 more classes. So we have, I think, probably 2 more weeks after this, right? 23, 30, and then 6, right? 2 more weeks from now. So by the early next week, I think it will be fixed.
ওকে স্যার।
স্যার আমার মানে ক্লাস লিংকে ঢুকতে আপনার পারমিশন লাগতেছে কেন? ওখানে তো টাইমটা স্যার 11:10 থেকেই দেওয়া আছে, নাকি আপনি আপডেট করছেন স্যার?
I did not update yet. I will update today. Okay.
ওকে স্যার, এজন্য পারমিশন।
So yes. After 12:10, it requires permission.
ওকে স্যার।
I will do it right now after the class. Okay. Any other question? But for the final exam, for final assessment or exam, whatever it is, it will be mostly the conceptual things like the routing algorithms, like the fragmentation, then TCP, then so most of the things will be you have to understand, and less things will be for memorization. So I think it will not be a problem if you go through the lectures and if you understand the concepts. Syllabus will be manageable.
40 মার্কের একটু মানে অনলাইনে এক্সাম দিয়ে স্যার আসলে অনেক ডিফিকাল্ট হয়ে যাবে স্যার আমাদের জন্য। এত মার্ক আসলে অনলাইন এক্সাম দেওয়া, টাইমটা ম্যানেজ করা।
I know, but actually it depends on the department's policy. হ্যাঁ, মানে ডিপার্টমেন্ট আসলে ধরো কমন পলিসি যেটা হবে আমরা তো সেটাই ফলো করতে হবে। তবে আমি তোমাদেরকে যেটা বলছি, আগেও বলছি, এখনো বলছি, প্লিজ ট্রাই টু পার্টিসিপেট, ট্রাই টু আন্ডারস্ট্যান্ড। See, I am covering the things slowly. I am repeating the things many times. So just make sure you understand the concepts. In that case, it will not be a problem. Even if 40 marks question, as I said, it will not be like writing so many things. Less memorization, more understanding. So you don't need to write large answers. ঠিক আছে, তোমরা জিনিসগুলো যদি বুঝতে পারো, আমার ধারণা যে প্রবলেম হবে না। এখন সেইটা একটু এনশিওর করতে হবে। আসলে 30 মার্ক 40 মার্ক এটা আসলে ম্যাটার না, ম্যাটার হচ্ছে যে আমি জিনিসগুলো বুঝি কিনা। হয়তো দেখা যাচ্ছে যে আমি 1.5 ঘন্টার কোশ্চেন করছি, অনেকের 1 ঘন্টায় শেষ হয়ে যাচ্ছে যারা ক্লাসের সাথে পার্টিসিপেট করছে। সো সেটাই আমি তোমাদেরকে বলবো যে এখনো 2 উইকস সময় আছে। ইউ ক্যান টেক হেল্প ফ্রম ফ্রেন্ডস, ইউ ক্যান গো থ্রু দ্য রেকর্ডিংস। আমি কিন্তু যেগুলো ক্যালকুলেশন আমি প্রচুর হ্যান্ডস অন এক্সাম্পল ইউজ করেছি। But don't understand the things from solution. That is one of the problem. যে আমি বইটা পড়িনি, বেসিকটা বুঝিনি, আমি জাস্ট সলিউশন দেখে দেখে ও আচ্ছা এটা এইভাবে হবে। That is the problem. You cannot understand a concept with solution. You have to understand the concept first with basic examples from the textbook, from my lecture. Then you go for the solution from your own. Then you match. তোমার ভুল হতে পারে, 10টা ভুল হতে পারে, কোনো সমস্যা নেই। তুমি বেসিক এক্সাম্পলটা ক্লিয়ার, তুমি একটা সলিউশন করো, দেন তুমি সেটাকে ম্যাচ করো, দেখবা তখন নেটওয়ার্কিংটা কঠিন হবে না, সহজ হবে। ওই জায়গাটাই আমাদের, আমি কিন্তু ট্রাই করছি তোমাদেরকে পার্টিসিপেট করানোর জন্য, বাট ওই জায়গাটাই আমাদের ওখানেই সমস্যাটা হয়। এনিওয়ে, উই হ্যাভ 2 more weeks. সো স্টিল যাদের যে ল্যাকিংস আছে, প্লিজ ট্রাই টু অ্যাকোমোডেট। Okay, so let us finish today's class. Any question? Any more question? Acha.
No sir. Assalamu alaikum.
Wa alaikum assalam. Thank you. See you in the next class.